PIM, Protocol Independent Multicast, to send IP multicast packets and receive them in the same subnet. It only needs all the network equipments in that subnet supports IGMP, Internet Group Management Protocol. For the multicast packets to reach the other subnets, the routers need to support DVMRP, Distance Vector Multicast Routing Protocol, MISP, Multicast Open Shortest Path First, or PIM. In our base platform to support multicast routing, we use PIM. For details about multicast, please refer to IETF RFC 1112. PIM is used to achieve the scenario that one sender sends out the IP multicast packets and expect the receivers on the other subnets can receive them. If the receivers are in the same subnet, PIM is not needed, it only needs IGMP for the case that sender and receivers are in the same subnet. Illustration 153, Scenario to use IGMP and PIM, and in our base platform, you also need to consider the impact of the policies between the zones. Please remember that the packets from Zone Net and Zone DMZ will be dropped by default. For the scenario shown above to happen, it only needs to turn on PIM at System Network Multicast Routing, Illustration 154, Setting for Multicast Routing. Illustration 155, After PIM is turned on. Only when the sender is located in the subnet that is not directly linked to the router should you specify the subnet and the associated interface that multicast packets arrive. Otherwise, you do not need the other setting, just turn on PIM. It automatically sets up the group-specific rendezvous point, RP. IP multicast is based on UDP so that it is not like TCP to have reliable transmission by knowing the arrival of the packets at the other end. Thus, to confirm if the PIM functions, you might check if the UDP packets are dropped due to congested network when the multicast packets do not arrive at the expected subnet. IP multicast is with the benefit that the sender only sends the message once and multiple receivers can receive the message. However, to prevent IP multicast traveling too far away, you might ask PIM not send out multicast packets to a specific network interface other than restrict the subnet of the sender. It can be done via System Network Multicast Control, Illustration 156, Multicast Control. The rendezvous point for a specific group address can also be set up statically. But this is not needed when we only have one machine, base platform. Routing across VPN. In this section, we consider to populate the routing entries across VPN. If possible, we consider to use RIPv2 or OSPF to do dynamic routing. If two routers can exchange routing entries either dynamically or statically, at least they have to have the access to the same IP subnet. Based on this idea, we look at a diagram we have and modify it a little bit. Illustration 157, two routers across Internet. In the previous example, we can establish the direct wiring, via Ethernet cables or switches, between the two physical ports of the two routers. However, the two routers are at different sites across the Internet. It is impossible to establish the direct link on the two ports. Therefore, OSPF or RIPv2 is impossible too. If the physical link is impossible, can we establish virtual link to bridge the two ports? We rearrange the diagram again. OSPF or RIPv2 can run on the same subnet if the two ports of the routers can be bridged. Hence, the problem turns out to be establishing site-to-site VPN in bridge mode. Of course, the VPN connection has to go through Zone Net to reach the other side. Illustration 158, two private routers try to connect across Internet for site-to-site VPN in bridging mode. We have a similar diagram to the setting above. However, this time we bring up OSPF or RIPv2 to exchange routing information across VPN. Illustration 159, OSPF or RIPv2 across VPN, in bridging mode.